This is lesson 8.7 as talking about fractions of a group. So if I were to talk about both of these collections and ask what is the fraction of marbles that are green, I would count how many are green. So there's 4 that are green, that is the part. Your part will be the numerator. And the denominator, the whole amount, is how many marbles are there all together. So you just count them up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 out of 12. So you would say 4 out of 12 are green. So that's when they're all spread apart. When they're all together and they're already grouped, you can still do the same thing. If I want to know the fraction that are green, I could say, well, one box is green out of how many boxes there are. So I could say one box or one part out of 4. So that's the first part of the lesson, is just naming the parts compared to the whole amount. Now, if I wanted to say, okay, well, 4 out of 12 are green, how many are not green? There's 2 ways I could do that. One is I just count the ones that are not green, or I could think of it like this. If there are 12 total and 4 of them are green, if I take away those 4, how many are left that are not green? There would be, put it up here, not green. There would be 8. 8 out of 12. So start seeing the relationship with fractions. So in this lesson, the denominator isn't talking about the size of the part anymore. Now it's talking about a total amount of things. So that's our whole amount. And the top number, the numerator, is specifically what is the part that we're asking about. So for the green part, it's 4 down here. For the not green, it's going to be 8, and the total amount stays the same. It's still 12 marbles altogether. Here's a super fast example. If I want to talk about these magnets and I want to know the fraction of magnets that have animals on them, so I count the number of magnets, 1, 2, 3, 4, so there are 4 that have animals. And the total amount, or the whole amount, is how many altogether? So 4, 5, 6, 7, 8, 9. So 4 out of 9 have animals on them. So without doing any extra work, I can then also know how many do not have animals on them. So I can count if I want to, but really the answer is right here for me. If I still have 9, I didn't change that. There's still 9 total magnets. If 4 of them are animals, I take away those 4, how many are left that are not animal magnets? There would be 5 magnets that are left. So I pretty much can do 2 problems in one, just with the same model. Here's the last part of the lesson. If we have to model fractions that are greater than 1, we first write how many holes are there. So we're talking about a bag of marbles, or a box, and how many whole containers are there? There's 3, so that would be our whole amount. If we wanted to represent this as a fraction, as a naming of its parts, how do we do that? Well, the top number is all of the parts. So how many marbles are there? There's 4, 8, and 12. So there's 12. And what do we put as our denominator? Do we put the 3 or 4? How do I know what to put as a denominator? Well, we're actually going to go back to one of them. And what is the size of the part in each one? It's a 4th. There's 4 in here, so it's 12, and the denominator will be 4. Now that might not make a lot of sense now, but it will as we move forward. And what you should recognize is there is a fact family here, and this ends up kind of being like division. It is division. So if you think of it, 12 divided by 4, 12 items divided by 4 is going to give me 3 wholes. So that's one way you can think of it when you have a fraction greater than 1.